Thanks, Lee. Great. So it's been actually more than a decade since I retired from 3M, and it's been just about a decade that we've been working in the Agile space, thinking about it in what does it take to make stuff happen. Agile was defined in 2000, right? 2000 or 2001? Anyway, close to a decade ago. And it's been growing ever since. And you'd think after 10 years we'd be there. And that's the question. Is it all over and there's something new? Or have we got a bit to learn yet? The first thing I would like to do is to take you to where I look at the world of software development. And I look at 3 different areas of the world, areas of software development, because it seems to make a lot of difference, not who's doing the software development or what the product is, but where the customer sits. So there's IT. How many in here do or supply services to IT organizations? Okay. And the customer there is inside of the company that you happen to work for. And then there's products and services, okay, where your customer is not actually inside of your company. How many do that sort of thing? Okay. And then I'm going to put it as a different category, I didn't warn you of this, embedded software, where, and the tools that support embedded software, where your customer actually, or the thing that you're supplying software for, is typically hardware or in support of some hardware. So how many here are in this world? A good amount, but not as many. And maybe I'll see why. The reason why I look at software through these different eyes is because personally, I happen to start out life in the embedded software world. And most of the actual code that I wrote was in support of hardware, diagnostics for hardware, driving control systems in big manufacturing plants, that sort of thing. So I'm going to start by talking about where we see embedded software today, because my ears always perk up when I run into people who do this, because it happens to be my first love. The interesting thing about embedded software is it is just exploding as far as the need for it to be done. If we didn't have embedded software, we wouldn't have cell phones, we wouldn't have computers, we wouldn't have computer chips, we wouldn't have airplanes, because they are now desperately require software in order to fly or in order to land because of the air traffic control. We wouldn't have refineries or any kind of control systems for big processes. We wouldn't have energy distribution, and lots of energy generation depends on embedded software. We wouldn't have our GPS systems in cars, and I don't know about you, but I travel a lot, and I just can't imagine not having a GPS system. We wouldn't have medical devices like pacemakers. Not only does the device have software embedded in it, but all of the programming necessary to make the thing work and to modify it over time is embedded. You could call embedded software because it's just as important as the stuff that's inside. We wouldn't have all of those electronic devices that we love to use. None of that, because it all requires embedded software. And I've been looking to figure out what is the percentage of software in the embedded world being written versus the rest of the world. And my feeling is that it's easily half, but I haven't got the data to back that up. Massive amounts of embedded software are in demand. And so that world, that environment, has some pressing problems. And the very first one is that there are not enough people to do the software. There's just not enough experienced engineers, not enough managers, or anything like that. If you take a look at this particular graph, what this is a picture of that we saw from a Toyota person who did embedded software process for Toyota about a year and a half ago when we visited Toyota in Japan. And he gave us a presentation about what is the company's most pressing problem was. And this is it. On the left side, you see the lines of code of software in various types of devices. It isn't big enough, but all you need to know is it starts out in 1997 and it ends up in 2010, which is now. Take a look at the exponential curve. That's how software is growing, from a couple million lines of code to like about 16 million lines of code in a car, and growing. And if you take a look on the right, you will see how many hours of people that they need in order to generate that software. And it's also growing exponentially. And he said their biggest problem is not having the engineers or the management experience to make that happen in a really good way. And that's not just cars. I hear it in the telecom industry. I hear it all over. There's a huge shortage of people that are experienced and capable of doing this sort of thing. That's really the biggest problem, is the growth. The second problem is intense competition for more features, for lower costs, for faster time to market. I see this most especially in the telecom industry, where one telecom executive told me a year or two ago, do you know what Skype and those sorts of voice over IP things has done to the telecom industry? They've taken $3 trillion a year out of our revenue stream. So all of a sudden, the telecom industry just doesn't have the kind of money that they used to have. But they certainly have the demand and the massive growth. And now with 4G coming along, intense competition. Competition that almost makes the industry, you know, on the dysfunctional side as far as bids and contracts and stuff like that. But they can't get enough people. And the pressure is so intense to outbid the other person that everybody bids impossible stuff. And they know it, but that's the way the industry works. And then there's ever-increasing complexity. Stuff isn't simple anymore. When I did process control, it was, I thought, complex. But compared to today, wow, it doesn't even start to shine a candle to the complexity. And it's not going to change. If you take a look at Intel's chips, you know, Gordon Moore was one of the founders, and he said he has Moore's Law. Like every 18 months, stuff goes up by a factor of 2. And so you've got this exponential curve. You've got the exponential curve if you look at the chips that they're making. You get the same exponential curve in the kind of software necessary to support those chips. So there's huge amounts of complexity that's just growing, and there doesn't seem to be any end of it. So if I were going to categorize these problems in the industry, there's first and foremost a shortage of people, capable people. And secondly, there is a market demand problem that they are struggling with. And thirdly, there's a technology problem of complexity. It's a huge, huge market. It is intensely competitive. It is frequently life critical. You know, medical devices and airplane controls are life critical. You don't want those not to work, okay? But you know, we just learned that also brakes on a car could be life critical. And all kinds of things that you do with embedded software have a tendency to fall into that area. And it's experienced this exponential growth. Now, what we see when we talk to people in embedded software is interesting, because you notice that not that many people raise their hands here, and that's pretty typical. Systems engineering is what drives embedded software. It's not the software that matters. It's the system. It's the hardware. And everything is a subsystem of an overall system, which is certainly not software. So the schedule, the requirements, everything is driven by the hardware. And even though in Agile we say, well, people don't know what they want, guess what? Hardware actually usually does know what it wants. And in fact, even though it's going to change slowly or not at all. And then if it makes a mistake, the software has to come in and fix it. So it's more likely that you will, in fact, have reasonable requirements in an embedded software environment. But the hardware drives the design, it drives the architecture, it drives the schedule, and all of that sort of thing. So what happens in embedded software that we see is that test automation's been there forever. The idea of writing automated tests as a new concept is, you know, that's a joke. I was at a place in Phoenix where they did helicopter controls. And I started talking about test automation. Test automation? We've had test automation since like decades ago. Our biggest problem is they're so big, they take so long to run, we can't run them frequently enough. I mean, they've been doing that forever. Early integration practices, even with lots of simulation, because the hardware isn't there, very, very common. And when you get into life-critical and quality-critical areas, you're really going to get some very, very good and very disciplined quality practices. A friend of mine in medical device systems says, just because we do Agile doesn't mean we don't do good systems engineering. And they know what they have to do in order to make sure that it's high quality. So we rarely see in embedded software this great big, let's fix all the problems when we integrate at the end concept, which always seems strange to me because I was working in this world. And when we brought our software to a manufacturing plant to start up a process, we expected it to be running in a couple weeks, even though it took a year to develop. And we never married it to the hardware before, because stuff works when you put it together in this domain, generally speaking. The other thing is that Agile hasn't really been that attractive to the embedded software industry because iterations, 2-week iterations, stuff like that, makes no sense. So the concepts of the way that we like to control projects in Agile doesn't make any sense to many people in embedded software. You don't drive your project with iterations. Sometimes you can do software iterations, but typically not even there, because what you tend to do instead is to drive by milestones or prototype milestones, where every couple, 3 months you have a prototype and then a prototype and then a prototype. And this has been going on like also for decades. And they don't need a new word like iterations to talk about it, and they don't think about 2 weeks as being the right kind of cadence in when you're developing against a hardware platform. Let's go on to another one. Let's look at software products and services. Before there was software, and I actually lived before there was software, okay, and there wasn't any email. That's the kind of phone that was in my house. Actually, when I was really a little kid, we lived on a farm in the summertime where it had a crank phone, but that's typically what we had. And then there wasn't any Google, so you had to get encyclopedias if you were really going to have anything in your house. You could look up stuff. And there wasn't any spreadsheets. You actually calculated stuff by hand. And there weren't road processors. We had typewriters. And you had to use like whiteout in order to change if you made a mistake. And I'm not being a good typist, that's the best thing that ever happened to me, was I wouldn't have to do that anymore. And you don't have video games. You actually played stuff like Monopoly. And we didn't have Photoshop. And my husband, being really quite the photographer, did all kinds of, processing of film. And then there wasn't Amazon. You actually had to go shopping. And there wasn't Twitter. You wrote in diaries, So before there was software, there was other stuff. And, but, we're not going back to this world. In the software and services environment, we have really, again, a kind of 2 different kinds of companies. The companies that have been around for a while and the companies that are just trying to break in. Because where there are entrepreneurs, and we run into a lot of them around the world, it's easy actually to be an entrepreneur in the software world because it doesn't matter physically where you are. You can move your software around the world with the cloud at almost no cost. So there's a lot of startups in this space, and then there's a lot of successful companies. The successful companies have a problem of how do we make sure that our customers keep on loving us? How do we not go out of date in an industry that has all these disruptive technologies coming in all of the time? So then the second problem that they have is, why does it take us so long to make changes to our code? It used to be that it could be really fast back when we were a little company, and now we have this massive code base. Now what do we do? So they have a technology or a complexity problem. And the third thing is, how are we going to be able to constantly innovate so that we can keep on getting better and maintain growth? So that's, again, a people problem. And companies around the world are having trouble, doesn't matter where you are, trouble finding the people that are going to come up with the good ideas to move them forward. Except maybe startups, they have a little less trouble. There, in startups, the real problem is, am I going to make it? Is this idea actually going to sell? Have I got the kind of idea that's going to make this company viable? Again, it's a marketing question, but a little bit different. And then a startup will have a bigger trouble saying, how do I actually track those people to get them to work for my company, which, you know, they may not trust. And then, you know, they actually think a little less hard about the problems of technical debt and stuff like that, because once they're successful, then they say, well, maybe we ought to worry about it, but not necessarily on the front. So in this area, you have people looking at it as an area of unlimited potential. And Tom and I have been in the last 3 months to Brazil, to Kiev, and Ukraine, and to China. And we ran into lots of people, and really smart people, really competent people that are heading out to figure out how to make their way in the world, and this is a really good place for them to do it. So there's all kinds of people all over the world that are really competent and saying, this is where I can start my company and start my business and figure out how to do new things. Market understanding is the key. If you make stuff that people won't buy, that's it, so much. Oh, and if you can't keep on making stuff people love, well, that's it too. Because there's too many people out there that are going to take away your market. And if you're profitable, it's even worse. Because profit is a magnet for competition. And there's lots of competitors out there. Understanding unrelenting change is a fact of life. In this world, stuff always changes because the market changes. And quality requirements may be key and may not. You know, it could be you could put up a website and, hey, if there's something wrong, you fix the link or something like that. So sometimes I find companies in this area who say, well, we deploy, and if there's a problem, we just back it out. And we discover that it's cheaper. So sometimes you don't see people that are really aggressively worrying about quality, and sometimes it's absolutely critical. So it kind of depends. So if you take a look at the various kinds of companies out there that are doing this kind of stuff, anyone from Microsoft and Google to Salesforce, who's trying to make a run at CRM and doing pretty well, Twitter and Amazon, and even we, that does, you know, nice games for kids, or not just kids, by the way, but all of us kids. What you tend to see in this industry is incremental delivery with regular updates. You don't start up a startup or even a big company and have everything done at the beginning. You do a bit, and you deploy it, and you get some money, and then you do some more. And this is really common in this area. Top companies pay careful attention to creating a compelling user experience, because that's where they capture the market. They pick up people because they love it when they first see it. Average companies don't pay enough attention to technical debt. They just get stuff done and get it out there, and as they get bigger and more successful, they are saddled with a legacy code base that they can't maintain. That's very common in this industry because of the race to get something out there really fast. And this, by the way, interestingly enough, is the context for which Agile practices were invented, and this is the context in which they work best. So this is the background of Agile. And then there's the IT area. There were a lot of people here from IT areas. And I want to show you something that Forrester wrote about thinking about IT. And again, thinking from the point of view of how you are thought about by your customers. There's 3 archetypes, 3 ways or mindsets of thinking about IT. One is the IT doesn't matter. You're just a utility. And then what you're supposed to do is provide cost-effective stuff like electricity. Give us servers, give us email, you know, just make it as cheap as it can be. And make it just average like everybody else. We don't need anything very special. And keep cutting costs. So that's one way to look at it. And then there's the supplier concept. Give us stuff that is on time and on budget, and give us what we told you we wanted. And this is common. And this is what I'll call the project environment. And sometimes, you know, if it's project environment, it becomes a contractor environment, because this is actually one of the environments which tends to drive outsourcing, because if you're a supplier, it doesn't matter that much if you're inside or outside. And then there's the partner archetype. And in this case, you're trying to work with a business and as part of a business to create differentiating and competitive solutions for the company's customers. You're thinking about the company's customers. You're trying to create really important stuff for them and for suppliers and for internal users. So those are the 3 archetypes. And at Agile 2010 here in Orlando in August, we had a keynote by a guy named Dave West from Forrester. And one of the things he talked about, in fact, the title of his thing was Product-Centric Development is a Hot New Trend. So in IT departments in the US especially, but also in Europe, he finds this concept of product-centric. And that means application development organizations are thought of as partners rather than as suppliers. You're actually trying to create products for the business unit of which you become a part. And it turns out that you have a very different way of looking at the world if you are product-centric rather than if you are delivery-centric focused. So if you're product-centric, then you are supporting a core differentiating business process, not just a average one. Your biggest concern is coping with change, just like in the product companies. Your application development is core to the business. Now think about it, banks, insurance companies. Actually, software is core to their product. It reports, the people in this kinds of area tend to report into the business unit and are part of it. And this seeks partnership with business stakeholders. And by the way, product-centric IT organizations are measured on business results, not on project results. Did we help the business get more money or save more cost? And they have a strong sense of ownership of the business results. The team does. And interestingly enough, there's above average focus on spending in quality and in testing. So he said that in his survey, in the vicinity of 54% of companies are leaning towards or are involved in a product-centric approach in the IT departments. So if I look at software in IT, the pressing problems I see are, first and foremost, monolithic code bases with brittle code. Does it sound familiar? Yeah? That make changes very difficult, and small teams and projects don't work very well. What we find is that Agile practices gone against a monolithic and brittle code base creates a huge dissonance because Agile wants to change code. And code doesn't want to be changed if it's big and monolithic and brittle. And you try to make Agile practices work there, and you have a lot of trouble. It's just not a natural. So you have a big technology problem. Secondly, there's intense pressure for lower costs, especially in the supplier model, or for sure in the utility model, because that's what matters, and that tends to lead to outsourcing. And then what you have is the company doesn't have people that understand how to do good software for that company because there's the pressure for outsourcing. So there's a people problem. And lastly, you have a really difficult struggle because there's a whole lot of benefit in having something centralized, and then there's a whole lot of benefit in having people in the business. So how do you balance the pull from the business with the need for certain centralized structures? So how do I decide what I should really do? And I'll call that a market problem because it's a where is my customer kind of a problem. This is from Neil Nicholson, who's talking here, and he talks about the way you think about in IT how you make decisions. And you think about, on the bottom line, whether or not you have a commodity or a differentiating type of a thing that you're trying to do. And on the vertical axis, you have routine stuff that you do, and then you have mission-critical stuff. Now, in the lower left here, if you're just doing commodity stuff, and it's basically routine, you actually can run that like a utility. You can say run your email or whatever like a utility. But if it's mission critical, even if it's commodity, but it's mission critical, then you at least have to be in the supplier mode. And any time that you've got stuff that's going to differentiate your company from its competitors, you should be in the partner mode. Because otherwise, if you're in the supplier mode and you supply, then anybody can do that. It's really the place when you're doing differentiating type software to work in a partner mode. And if it's differentiating plus mission critical, you'd better be an essential partner of the business. You really, really need to be in there somehow. So, now I've talked about the three different types. So when you're looking at what should I do in order to get better than where I am, the first thing I suggest that you do is solve the right problem. And there's three essential problems. One is a market problem, one is a technology problem, and one is a people problem. And depending on your context, you're going to have one or the other. The third is your primary problem. If your market is the problem, the most important thing you need to do is to build the right thing. Make sure that what you're doing is worth doing and is what needs to be done. If you're in the area where your biggest problem is technology, then you want to make sure that you have your act together on quality and you build the thing right. But if getting good people is really the problem, and we see an awful lot of that, then there is another way to think about it. And I'm going to touch on this at the end, and that is treating workers like volunteers. But I'll move on from that and start with the market section. So, build the right thing. One of the interesting things that I always hear is, oh, how does Apple do it, right? Simple, easy designs. And when I look at it, I was wondering, and I wondered this, way back in 2000, why everybody was talking about how hard software was, and I took a look right in front of me on my terminal, and I was on this thing called Internet. And Internet is huge. It's massive. It's interconnected, and it's only gotten bigger and more interconnected. Imagine this massive code base. Why isn't it falling apart? I mean, every other massive code base that I've run into has real problems with scale. Somehow this thing doesn't scale. So back in the 1970s, the TCP/IP architecture, which became the core of Internet, was articulated. This is the 1970s. And it's 4 simple statements. This is an interesting architecture because it's very simple. It's no internal changes are going to be required of a network, and they thought of everything like my computer as a network, in order to be connected to the Internet. So I don't have to do anything to my computer to be connected. Communications are on a best efforts basis. That's interesting because up until then on ARPANET, you had to actually acknowledge back, and that tended to hang things up. No information is going to be retained by those black boxes, which are gateways and routers and stuff, that's connecting the networks. They'll pass stuff through, but they won't maintain information. They're not going to be required to. And there will be no global control at the operations level. Period. End of discussion. This is the architecture. And the architecture in that statement became something that was extremely simple and something that anybody can connect to and is used around the world and has only gotten bigger. It's very hard to imagine the world without it anymore. And it's one of our most important core infrastructures. And this is a way of thinking about a simple architecture. It took a long time to evolve to what it is, but on the other hand, it didn't take that long to make these statements about it. ARPANET had been in test with little IMPs, little mini computers that were the gateways for about a decade. And interestingly enough, these mini computers got obsolete. And they said, oh, that's bad. If you can think about it, they got obsolete in about 10 years, and so they had to figure out how to replace them with something that wasn't going to get obsolete. They were having hang-ups requiring the acknowledgments. So these rules came from about 10 years of experience of how we don't want to do it. And they had to force a cutover, but anyway, it's simple. That's a simple architecture. And then there's this. How many have the iPad? Like it, yeah? And they, the first day they were out, they just sold they're very simple. Apple does simple designs. In fact, some friends at Nokia said to us that the day the iPhone came out, they had to take 5 years of user interaction research and toss it out the window. And we used to do classes for people that did user interface design for cell phones, and they had a 2-year cycle time. And I kept saying, geez, that seems long. Well, we can't download it. Once the phone's out there, it'll never be able to be updated. And I'm thinking, geez, that's kind of strange. And then, guess what? It turns out that wasn't necessary. So simple design. If you take a look at the way Apple does stuff, it's how much can I not do? This is the flip video. Up until then, video cameras were expensive, and they were hard to come, and the market was absolutely flat. And the year after the flip video came out, the market tripled, and 95% of the growth came from this little handheld video camcorder. And just has sold like mad. Now, you can do the same thing on your cell phones, but actually, people still buy that, lots of it. Way more than they've ever bought the video cameras. Simple design. This is Google interface in 2001. Now, in 1999, every single portal out there had what they have today even, junk, just tons of junk. And then Google came out with like one line. Their goal was, how do I get people off my page as fast as possible, instead of how do I get people on my page? And that changed the way you thought about what a portal ought to be. And this is a ultrasound device. It was actually invented in China by GE Medical Systems, by a Chinese team, because they discovered that they really didn't want to have a US medical device brought into countries like China and India where they had different problems. Why don't we create an in-country team that understands the problems and make something that'll work here? And they've done that in India with EKGs, and with this sort of reinvented the concept of ultrasound. This is a little tiny cell phone size thing, costs maybe $8,000 against something that used to cost $100,000. A massive disruptive technology. GE Medical Systems was smart enough to disrupt their own market. And it's very, very simple. And it does massive amounts of in-office diagnostics that used to just not be able to be done. Maybe it's not quite as sophisticated as something that you're going to get for $100,000, but it does a huge amount of good. So simple design means focus on only what's necessary. It means how much can I not do? Steve Jobs says it's only by saying no, and no 1,000 times, that you can concentrate on the things that are really important. And the key designer that he has had at Apple since he came back is Jonathan Ive, who says, more features make a product forgettable. And this is by Tandberg founder, and Tandberg is the one that makes these telepresence videos. Really, really useful kinds of, a successful company. And he says the worst thing you can do is what customers ask. That's not what you want to do. You don't want to do what your customers ask for. You have to understand their problem and you have to solve it. And that's what made his company successful, because he drove this philosophy into every single engineer in the company. And finally, just one last thing on simplicity. Don't ever, ever, ever automate a process without simplifying it first. Too many times they say, well, this is a messy process, let's just add a computer to make it simple. Wrong. First, simplify the process and then see if you need a computer anymore. So simplicity, what can I not do, is the first thing that you want to think about in building the right thing. The next thing is systems engineering, and only so many people do systems engineering. Typically, it's common in embedded software. Typically, it's not common in the other parts of the software world, but it's a good thing to think about. This is Tom Gilb, who had the first person who talked about what we call Agile, but he called it Evolutionary Design. And he's been writing about it since the early 1980s. And he recently wrote an article which basically says, let me take Agile to task. Agile can be a tool, okay, but it shouldn't be the master. And one of the first things you should do when you're thinking about a project is to start with business requirements, not requirements. You get one page, that's it, no more. And you should have a handful, 10, 5 business requirements. Make sure they're not technical. And give the development team the freedom to discover how to deliver those results. Don't tell them. In fact, he says the worst scenario I can imagine is when we allow real customers, users, and our own salespeople to dictate functions and features to the developers, because these are carefully designed requirements which really are their guesses at what it might do. Maybe even our product owners try to tell the team what the requirements are. If you go slightly below the surface, these are false requirements. You're going to find that they're not really requirements, they are really bad amateur design for what the real business requirements are. You want design to be done by people who understand design. And historically, the design has been done in the technical area, not by customers having a problem. So you, first of all, in development, should estimate the impact of the designs that you are proposing on the business results. This is step one of deciding what to do. Have the development team design and estimate the impact of that design on that measurable business number that you're trying to move. And then select the designs with the best value and impact for their costs and do them first. And you should focus on value estimates, not effort estimates. Not quite the way some of our Agile practices tend to talk about this. But he's been in this world for years, and I suggest he probably knows a little bit about systems engineering. And lastly, he says, there are a lot of stakeholders. There's never one, and it's not a good idea to have one representative of the stakeholders, because it's not really possible for one person to understand the richness of the multiple stakeholders out there, and the person is likely to become a bottleneck. So the whole development team needs to have a line open to that array of stakeholders. So we don't quite do this yet in Agile, and I think we may think about whether or not there aren't some good ideas here. Here's a book that you might read that talks a little bit more about it. And then there's this whole team. So if I have one complaint about Agile, it's been that Agile is all about software. And you know what? From our customers' perspective, they don't care about software. That's not the thing. And we get too tied up in making sure the software is the really effective piece. And anybody that knows systems theory knows that when you optimize a piece, you suboptimize the whole system. So if we focus just on good software, we for sure are going to suboptimize the overall thing we're trying to deliver, which isn't software. It's some sort of customer, business, valuable thing that they need. And you need to think all the way up to that piece in order to get it right. So when you're building the right thing, you need to think about whole team. And here's a story, which I told yesterday afternoon, so a few of you might be a little bored here, about a large, successful website in Norway, but they had divided themselves into vertical markets. 6 vertical markets plus an underlying platform, and then there was a mapping kind of a team. So they had like 8 teams. And each market had its own team, and each market had its own product manager. And interestingly enough, those product managers knew exactly what numbers on the website would drive revenue. They certainly knew that. I mean, that's their basic job. And when we came into the company, they said, oh, we're just having this big problem. You have to help us figure out how to do this product owner thing. And I said, well, let's see what's going on here. Because they were really struggling to produce stories for the teams. The product managers oftentimes had another person there to do that. And they're just added to keep up. And the teams were kind of struggling with what do we do next and how do we do the right thing. So I said, well, you got any teams that are working well? And they said, well, actually, we do have a couple. And I said, well, let's just see what they're doing. Well, the teams that were really working well didn't actually do this. Instead, the product managers had conversation with the development team once every month or two, saying, boy, I'd really like to have these features here. And the team would say, well, you know, I can't quite do that. And so after a few hours, they'd come to a conclusion that we could do these, and you know, before Christmas, 3 months from now, you'll probably have these things, but not those. And then the product managers took the web analytics that were driving their revenue, and they made trend charts. And they displayed them all the time, every half an hour they refreshed in the team area. So the team set off to do what they said that they thought that they could do, and all the time when they would deploy, they could take up and look at where the trends were going. And they would adjust based on whether or not those analytics were going in the right direction. Those teams actually were doing really well. It's because the team members would show up for work in the morning, and their job was to make those numbers go the right direction. Not to do this, you know, pile of stories that I agreed to do on in the next 2 weeks. And yes, they worked in iterations, and yes, that they did eventually have stories, but that's not what it was about to the developers. It was about making those numbers go the right way. And those were the particular teams that were really successful. So they were really engaged in making the business successful, and guess what? Those particular business lines were doing better than the others. So in looking at building the right thing, there's important things that you need to do if market is your key problem. But what if technology is your key problem, which is more likely in an IT department? And then the most important thing is to build the thing right. So the first thing about building the thing right, and the thing we find in way too many IT companies, is complexity. I call complexity the cholesterol of code. You don't see it, it builds up, it blocks all the arteries, and nobody even knows it until all of a sudden it blocks something down and kills you. Does that sound about the right analogy? I get that from Michael George. And that's what you can think about with complexity. It's cholesterol. You got to avoid it, just like bad cholesterol. So if you think about it, the cost of change as you increase complexity isn't linear. So the more complex your code, the more cost it's going to be, and the longer it goes, the worse it is. So if you don't have a simple, clean code base, you are going to be going up this curve. There's no question about it. In fact, Jim Highsmith says the real problem is that by the time many organizations are paying attention to their code problem, their complexity problem, it's too late. They've got a big legacy code base, and all of the solutions are bad ones. First of all, you could do nothing, and guess what that's going to get you? It's going to get you faster where you've been going so far, and that's not a good solution. Secondly, you can replace or rewrite the software. Okay, this is expensive, but not only is it expensive, it's very high risk. If you look at some of the crashes of product companies in the past, it's because they rewrote their code base and they set on a new one and it just didn't work as well as the old one. And it doesn't actually really address the root cause of the problem. How do you know? I have seen companies create a brand new code base, they're about to deploy it, and it turns out it has just as many problems becoming legacy as the old one. No test harness, no attention to quality in the new code base. How long is it going to be before that one is impossible to change? Or you can systematically invest in incremental improvement, which is the best approach. But how many companies do that systematically and over time? Not that many. But that's what you probably need to do. So let me ask you this. Just think. Are we there with Agile yet? How much time does a change take to your key code base compared to 2 years ago? Is it much longer? Or compared to 5 years ago? When you were smaller, when things were simpler. How much time does it take to make a change? I hear again and again, like this company in Norway. We used to make changes like really fast, and now it just takes forever. Why? Well, okay, that's going to happen if you're not paying attention to technical debt. Are your development and maintenance costs decreasing over time? Jim Shore writes that the fundamental objective of an Agile process is to decrease the development and maintenance costs over time. I deal with flat, okay? And I was at a company 2 weeks ago, big company, and the VP at the end of the thing got up and said, "We are not going to have cuts. We're going to be funded at a flat level, however. And this is the expectation of the business for us to deliver, and this is our funding. So can we, with same funding, deliver more? Or can we deliver the same and decrease our costs? Do you have competitors who can make changes faster than you? Because if you do, that's a problem. Unless they get unless they're on their way to a legacy base too. But what we see, again and again and again is these new companies can start up and they don't have all that legacy to deal with, and it's cheating, right? But either they're going to get the legacy or they're going to be smart. And so this is a big thing to think about. Technical debt is immense. And we saw from Michael Ma yesterday a picture of people doing various types of Agile development. And a lot of them were, yes, going faster. And yes, they were having fewer people, but guess what? They were having more bugs than an average other, a typical project across the types of projects that were out there. More bugs. Well, that's no good. That's not Agile. If you are more rapidly generating bugs than you could before, That is an interesting short-term solution, but it's going to create you a massive long-term headache. If you are creating more bugs, if it takes longer and longer to make changes, you're heading down the wrong path. That's not Agile. If you don't have the discipline of really good quality and finding the problems when they happen, then stop and fix your Agile problem, because that's not going to work for you over time. The next issue is escaped defects, because we have this thing called TDD, which typically means unit testing, and we have this thing called continuous integration, which typically is done at the application level. And so this is good, because you know what? I don't care what process there is out there. It's waterfall or you name it, going all the way back in history. Everyone out there has been put in place so that you can find and fix defects as early in the process as you possibly can. Honest. If you read the literature on the waterfall process, the idea was you find the defects during requirements. And actually, if requirements don't change from the time that they're written until the time that you're deployed, and you get all the defects out of there, that does in fact help you to create better code. But the problem is that if your delivery time is shorter than longer than your change time, and you change all the time, then you can't get the defects out during requirements time. So every process out there was designed to find and fix defects as early in the process as possible. Now, how good are we? So we go around the world and we ask people, you have a release cycle, and most companies have a release cycle. Now, if this release cycle is 3 months or more, so I ask this question. Say you have a 6-month release cycle. So how long do you take integrating stuff at the end, systems integration, UAT, all of that sort of stuff, before you actually go live? You know, where in that cycle do you do it? And typically, we see, if it's a 6-month cycle, we want to have that last 2 months for, code freeze, integration test, UAT, stuff like that. So what you got here is you're spending 2/3 of your development cycle putting in bugs to find in the end. Why? Because they're only doing app-level testing of integration, not system integration early. That happens at the end. And of course we find problems there. Well, coming from the embedded world, of course you don't. But people think, of course we find problems at the end of our development cycle. Sometimes we see 50%, sometimes we see more of an overall release cycle spent finding all the problems that got put in on the front. So we got to get over the idea that this is good. We have to not just do continuous integration at the app level, we have to start figuring out how to do continuous systems integration. Early anyway, at least at the end of every iteration, you should be driving into system test. The really good companies that get this, they might spend 10% of their time doing final testing, and then they'll shorten their cycle. Now that doesn't mean no verification at the end. It means when you have verification at the end, you should be surprised to find problems. So when we do value stream maps, I ask people, so yeah, there's your systems integration. Do you find problems there? And they say, well, yes, of course. And I'm thinking, no, not of course. Because of course you shouldn't. But we have in our heads, especially in the software product and software IT worlds, that when you go into systems integration, that's so that you can find all those problems. Wrong thought process. Of course, you should not be finding problems at that point. You should be finding them earlier while you're developing the code, and we need to figure out how to get some stuff in place so that we do. So we have to think about test automation on a much broader basis than TDD and continuous integration of that little code base. Do we do modeling to begin with, simulations, so that we have something to test against? Not too often, actually. Maybe we could do more of knowing where we're going, so making sure that it's simple. Do we do static code analysis? How many do? Not too many. How many do unit testing? Automated unit, yeah, see? That's why I got a check mark there. That's become common. If you're not doing automated unit testing in a framework right after you write the code, well, then you really aren't Agile. And really, that's considered kind of good professional practice anymore. There are some code generators that are really tough to test at the unit level, but generally speaking, most code can be tested as a unit test framework right away, at the same time, right after it's actually coded. Continuous integration at the application level. How many do that? Yeah, quite a few. Not quite as many as the other, but you know, why do you do the unit tests if you don't do continuous integration? It's kind of part of the same package. But what we don't often do is break it into components and simulate those components all the way through to their final thing. You find this commonly in embedded software, very rare in other kinds of software. But I did it when I did my process control systems. End-to-end testing. Automated end-to-end testing. Automated application testing things. Is that common? How many do that? So it's not as solved a problem as the automated unit test. It's more complicated, and you can build up a big complicated code base really fast if you're not careful. So people are chasing down this path and trying to figure out how to do automated, higher level end-to-end testing earlier in the process. Some are doing it well, and this is a problem that's not solved yet. We need to do more work in this area. A system integration tree, which drives integration all the way up through, so as soon as I get at least at the end of my iteration, I integrate at this level and then a bigger level and then a bigger level, all the way out through the user. That's not really commonly done in big code bases, but it's going to have to be done if you're going to want to figure out how not to have that great big back-end testing. You have to have done it already. Regression testing, and I mean automated regression testing, very important and sometimes done pretty well, but oftentimes this is still a manual end of the process thing. Problem there is, what do you do if you find problems? Well, you got to categorize them, critical, you know, that sort of thing, because you don't have time to fix them. You don't want to be finding problems in your final regression testing. You're supposed to be surprised. Because if you only see 2 or 3, you can do a root cause analysis and say, whoa, what caused that? So it never happens again. User acceptance testing in an automated way sometimes, not necessarily. We need to get better at that. And what I find that people don't do, but that makes all of the rest of this work, is when something escapes. And by escapes means I send it into a regression test or an end-to-end test and expect it to work, and it somehow doesn't, especially at the integration level. That's an escape defect. Do I have so few of those that I can do a root cause analysis, understand what caused that and made it happen, and change that so it can never happen again? So we have this concept of deployment automation. You've heard of continuous deployment, a couple of sessions on it in this thing. Those are the companies that can deploy immediately live. And they've done all of this stuff in order to make that happen. So that's where we're headed, but we're not there yet. And lastly, treat people like volunteers. Remember the times when you were deeply engaged in something, you know, distractions disappeared, time evaporates. My husband accuses me of this when I'm writing, for example. This is called Flow. In his book by Michael Kaminsky, it talks about being in the flow. And it looks like this. You can be bored, or you can be so threatened that you can't operate. But when you're being challenged, you're in this flow channel, or what Dave yesterday called in the groove. Okay? Things are just happening. That's where people like to be. That's what makes people feel engaged in what they're doing. And there's this book by Daniel Pink that says, when people are going to be doing stuff that they like, then they're looking for autonomy, they're looking for mastery, and they're looking for purpose. Now, the problem I pointed out to you is there's not enough smart people in the world to do all the software we need to get done. They're just not there. But they are there. They're just doing somebody else's software. Oftentimes, they're doing open source. Now, open source has been called the impossible public good, because if you know anything like tragedy of commons, it should be impossible to have a common software maintained by volunteers that's actually going to work over time. But guess what? Things like Linux, for example, incredibly stable and possibly complex. No monetary rewards for the developers, no sanctions if they do bad things, at least monetary, no central authority in the traditional sense. It defies all known social and economic theory. This stuff shouldn't work. But if you're looking for people, because there are not enough of them, that's where they are. So the fact is that it's not just about markets and hierarchies anymore. It's about making peer networks work. So, and again, I apologize for those of you who were in my session yesterday afternoon, but I want to talk about Mark Shuttleworth. Because Mark was an interesting guy. He grew up in South Africa, and he started a company, and he got it bought out by VeriSign after 4 years, and he had whole buckets of money, like, you know, 6 million or so. So he always wanted to be an astronaut. So he decided to be an astronaut. He paid, you know, 20 million, and he spent 18 months, and he got to be a cosmonaut. Okay, now that he'd done everything he'd always wanted to do, and he's still young, and he has still maybe, you know, quite a bit of money left, what's he going to do? What he decided to do was to bet this money on a company called, on an operating system called Ubuntu. He founded Canonical, which was going to support the development of this open source thing, because he wanted to be able to have inexpensive operating systems for his, for the children in like South Africa and other places without having to pay a big tax. So Ubuntu was the Linux distribution that was going to be easy for everybody to use. And he actually funded the development of tools for that and that sort of thing. He poured a lot of money into it, but he could not have bought the developers who put Ubuntu together. He didn't have even close to enough money to do that, as much money as he had. So he invested in a bet. His bet is, I can attract volunteers much faster than I can pay people to do the work. And he won that bet. Everybody I've run into around the world is complaining about not enough people, but I have worked at Canonical quite a few times, and that's not their problem. Their problems are different. So the thing is, Ubuntu has won the minds and hearts of people, has massive numbers of very smart people that are contributing to it. So think about that. We have a new economic landscape here. And if people are your problem, the people have to be thought of as wanting to be attracted by the stuff that motivates them, autonomy and mastery and purpose. So we have got to move to version 3.0 of people. Because economics is the study of scarcity. And it used to be that what was scarce was money. Not true anymore. You don't even need money to start up a good software company. You just need a little bit of time and some very bright people. And a cloud. And that's about it. I can see this happening, you know, in Brazil and in Kiev and Ukraine. And there's lots of entrepreneurs out of there. So the new scarcity, and therefore the new focus of economics, is the time and energy and brain power of bright, creative people. That's what you need, and you need to figure out how to get it. And the new motivation, the new way to think about it is not, let's have bonuses. It's autonomy, semi-autonomous teams with a good leader. It's mastery, giving people something that they can be really good at, proud of, in the groove, in the flow. And purpose. People need to know why they come to work in the morning. That's why you need to connect the team to the real requirements so that they have a purpose for coming to work in the morning. In the teamwork area, we're looking for semi-autonomous teams with internal leaders that have end-to-end responsibility for delivering results. Not just, let's do the software, but let's deliver the business results. And if you're looking for passion and people really being engaged, then people need to know why. And by the way, in the charter that I always tell developers when I give talks is, follow your passion. Do what you're passionate about. And be great at what you do. And then you'll be in the right job. So this is where the next generation of developers are coming from. This is what they're looking for. And if you're having trouble finding people, that's where you need to go. Thank you.